This is my user's guide to complete anatomy. This is undoubtedly my favourite anatomy app, and I think it's fantastic for teaching and learning. It looks good and is also highly accurate as well, which are the two things I'm mainly looking for in any anatomy app. So I want to take you on a bit of a tour of it. Here I'm looking at the atlas of the body, and I've chosen the anterior compartment of the forearm, looking at the superficial muscles there. And you can see when I bring that up, immediately all of them are labelled. But then I can move that forearm around. I can highlight individual muscles just to check which ones I'm looking at. And if I click on those, that brings up a whole load of information about them. So that's the wonderful thing about complete anatomy, is that you've got these very neat individual labels, but actually there's all this text there as well. There's all this extra information that's easy to get at. Now I'm going to look at the same muscle that was pronator teres in that flexor compartment of the forearm in a different way. I'm going to go in and have a look at the whole body model, and I can add on the skeleton and the connective tissues and all the muscles of the body. And now I'm going to search for pronator teres, and there it is. It's pulled it up and it's shining out in yellow. I can isolate it and look at that muscle on its own. And this is great because you can clearly see the attachments. You can see the origin and insertion of that muscle. And then we can put it back so that it's amongst all the other muscles. So we're understanding its position and its relations in the forearm. And once again, I've got all that extra information just there at my fingertips. And we can look at different attributes of this muscle. So if we want to look at the innervation, for instance, we can click on that, and then it zooms out and it shows you the brachial plexus and the median nerve coming down the arm there to innervate that particular muscle. We can look at the arteries that supply it. We can also look at its movement. So this is wonderful. Suddenly this model becomes really dynamic, and we can ask complete anatomy to show us what that muscle actually does. And with many muscles, of course, there are a whole range of different movements, and you can choose to look at each one. So there we have that pronator teres glowing as it contracts and pulling the forearm into pronation. I also like using some of the other tools in complete anatomy. We've got the ability here to add our own notes, our own writing. So I quite like using complete anatomy in live lectures, and that's great if you're in a lecture theatre with Apple TV, for instance, where you can just throw what's on your iPad easily up onto the screen, and you can draw over the structures that you can already see on complete anatomy or add labels like this. And I also use that when I'm making anatomy videos for my medical students as well. And there's more. With that muscle highlighted, another thing we can do is look at common pathologies. So I can go to the pathology button just there and then pull up a particular video on a particular pathology.
Golfer's elbow or medial epicondylitis is a painful condition of the elbow caused by overuse or inflammation of the tendons of the flexor muscles. Overuse of these muscles can cause microscopic tears in the tendons where they attach to the medial epicondyle, causing inflammation and pain on the elbow and weak grip strength.
So there are lots of videos embedded within the app like this, but there are also whole courses, in fact, that you can access through the app. So for instance, I can go into courses here and I can look at undergraduate human anatomy and then pull up something on the muscles of the lower limb.
Hello, my name is Dr. Alan Detton, and in this lecture, I will be going over the muscles of the lower limb with my colleague, Dr. Erin Fillmore.
There's also lots of radiology within complete anatomy. So this is great because we see the radiology alongside the model of the body. So it's easy just to look across from the radiograph to the body model. What should we have a look at? Let's have a look at the cervical spine. So there you go. There's the spine within the neck, and you can see all of those pins labeling it up. And if you just go and click on one of them, so 25, the vertebral body of the 7th cervical vertebra, it also shines out. It's picked out on the model to the right as well. And you can do that with any of those pins. There's the occipital bone. There's the posterior arch of the atlas. Back to the full body model then. I really like freestyling with complete anatomy, and I encourage my students to do this too. This is like sitting in the dissection room and just being able to look at the body, to move things around, to really understand the relationships of different structures one to another. That's something that takes a long time to build up in anatomy because, of course, this is a three-dimensional jigsaw. Being able to strip away each of the body systems, put them back in, see how they relate to bones, see how they relate to other muscles, for instance. So we've seen the nerves, now we're seeing the respiratory system. And if something's a bit obscured, then you can make it easier to see it. I'm going to pick off the sternum there so we can get a better view of the lungs inside the chest cavity. Every time you click on an individual structure, it gives you the option of isolating it and looking at it on its own, and then you can manipulate it. And this is just fantastic because this really gives you a 3D appreciation of that bit of anatomy, in this case, the temporal bone. We can put it back in the skull so we can see nicely how it fits there. And we can also ask Complete Anatomy to show us the various parts of the temporal bone. So you can see there that the squamous part is lit up in one colour, the petrous in another colour, the mastoid process in another colour again. This is one of my favourite tricks on Complete Anatomy, the explosion of the skull. So we just isolate the skull itself using the marquee tool, so you can easily make multiple selections with that marquee tool, and then explode the skull out. And again, we can turn it all around. So now those bones are separated out from each other, but we can see how they'll fit back together, and we can still click on individual bones and pull up all the information. So we're facing lots of challenges with teaching anatomy at the moment. Some of them are challenges that have been there for a while. Not every university has a dissection room, and so we've got to think about other ways of teaching anatomy that don't necessarily involve that hands-on teaching with a cadaver. And of course, over the last year, we've had to deal with the fact that a lot of our students are learning remotely completely because of COVID-19. So really, that's made all of us who are teaching at universities look very carefully at different ways of teaching, at the methods and the tools that we've been using for remote teaching up until now, but really looking at how we can maximise the benefits of those. And I'm sure that a lot of this will carry on when we're out of COVID, when we're on the other side of this pandemic. We're learning things about teaching and learning this year because we have to. I think actually what we're doing is coming up with some really interesting, creative new ways of teaching and learning that will bring their own benefits and that we will probably stick with a bit in the future when we emerge out of the other end of this pandemic. One of the things that I've been trying to do is to bring my broadcast experience together with my teaching experience and to make films for my students. And for me, anatomy is such a visual subject that I've also enjoyed bringing some drawing into my anatomy sessions with my students, doing some live drawing sessions, but also producing some videos where I've drawn, in particular, embryology. This is my very first lockdown embryology video. I'm Professor Alice Roberts, and embryology is one of my favourite subjects, how we get from being a single cell to being a complete human being. So we're starting right at the beginning. So in these videos, I sketch out the anatomy. Here we've got the anatomy of the female reproductive system. This is the first of my lockdown embryology videos where I take the egg from fertilisation through to the end of the first week where it's implanted in the womb and talk through what's happening at each stage. So it's also chronological. And my students have responded brilliantly to this. A lot of them have made their own sketchbooks as they've been learning, and they've shared those with me, and they've said that they found it a really useful way to learn, in this case, embryology. So I made a whole series of videos on embryological development, and actually those are available on YouTube as well. So I've had colleagues at other universities other than Birmingham where I teach using these videos for teaching as well. And I've made a whole series of lockdown anatomy videos, and for those videos I've chosen to use Complete Anatomy, and my students can either follow along with the app themselves. We have a subscription to that app at Birmingham University, or they can simply watch and learn. I'm an anatomist. I'm fascinated by the structure of the human body. I always have been. I'm going to be using a fantastic app. Anatomy is such a visual subject, and I think this is one of the best apps out there for learning anatomy in a virtual way. And it's called Complete Anatomy. It's from 3D4 Medical. Now, many universities have a subscription to Complete Anatomy. So if you are a medical student or a science student and you're at a university with a subscription, you can follow along using the app. So here we go, the bones of the upper limb. And here they are. So I'm manipulating these on my iPad. I can zoom in and look at the bones in more detail if I want to. And we'll start off by looking at the bones which connect the upper limb to the axial skeleton. And again, I think what's lovely about Complete Anatomy is this way to make it very personalised with my own writing here over it, and to really give that sense of three-dimensionality. I mean, that is the amazing thing about this app. And the way that you're not just looking at images of 3D, you can move it around. And I think in terms of learning that, of really understanding the three-dimensional makeup of the human body, there just isn't a better app out there. And I say that as somebody who's used lots of different online anatomy platforms. But when I saw Complete Anatomy, it blew me away. And I immediately contacted the creators of it and actually went out to Dublin to meet the team. And what really impressed me was the attention to detail and the fact that you've got a team of amazing illustrators and app developers working with medically trained people who make sure that all of the information, including the visual information in this app, is as accurate as it possibly can be. So I think there are so many ways to use Complete Anatomy, and hopefully I've covered a few of those in this user's guide. There's so much within it that you could construct a whole course in anatomy simply using the off-the-peg material that's already there. Or, as I've shown you, it's easy to adapt it to your own teaching and to produce your own material with it as well. I love it as a learning and teaching tool. So I'm just going to end with a little section of a video where I'm using Complete Anatomy to explore the structure and function of the hand. Hello, welcome to Lockdown Anatomy. I'm Professor Alice Roberts. I'm a clinical anatomist. Let's look at the palm of your hand to begin with. And in turquoise, I've just picked out that tendon at the wrist, palmaris longus. Here it is isolated, just the flexor retinaculum and the bones of the wrist and the metacarpals. The ones that you can see here are the palmar interosseous muscles, and these little muscles are going to contract and bring all of your fingers in together. In other words, they're going to adduct the fingers. So the palmar interossi adduct. Thanks a lot. See you next time.